Hello everyone. So last week I posted why I'm starting DSA after such a good number of times in and good number of years in my tech career and why I'm doing that. Today I will be demonstrating the first lead code problem that I solved recently, and I did few of other sums as well in this whole week. But I would like to start with my first problem and what I was feeling about it, so you can understand and relate to this and understand that you're not alone. We all feel the same when we start something from beginning, when we are somehow like conventionally we are very much ahead in the career, and then we are taking a step back and many step backs, and then we are starting our journey. It's a bit painful as well and uncomfortable, that's the right word. So when I started with this problem, that is two sum problem is the easiest, or one of the easiest at least, in the lead code, and everybody begins with that question. So I will begin with discussing the problem first and describing the problem first. It's a very easy problem. Let's see. So it's the two sum problem. Given an array of integers nums and an integer target, return indices of two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So we have been given an array, we have been given a target, and we need to tell which two numbers from the array add up to that target. A very simple, right? The brute force approach that comes to, I think it comes to everyone's head in the beginning, that you go through each of the numbers, add them together, and check that if they are adding up to the target, and if they are, just send the indices back. And that is how I also thought, and that is how I also solved the problem in the beginning. So if I go through my submission, if I so see, I did the same question last year as well in 2025, and yeah, so the solution that I did, no, sorry, I mean, yeah. So if you see, I did the same. I did like nested loop and checked the numbers, number I, number j, and checked if they are summing up to target, and if they were, return I and j. That is how my brain works. And I didn't have any idea that there are things like we need to find out within, because I wasn't thinking about time complexity or space complexity, nothing. uh, because I never did lead code style of problems before. So it wasn't a thing that would come intuitively to me. I thought the problem is solved and I'm done. But then I started learning DSA now. I will talk about how I am learning and my strategy and everything in a different video, but today I will just talk about this problem. So now let's come to the solution that's the most optimal solution. So now I will be going through the most optimal solution, and for the optimal solution I will be using hashmap. Why are we using hashmap? Because time complexity for retrieving any of the element from hashmap, basically we will change the array to the hashmap and we'll show how it is, and the time complexity is will be for retrieving or for searching any value is going to be in a constant time and the order of 1, and that saves a lot of time, because in when we are searching element in the array, we need to go through all the elements, as we know, in the brute force approach, and it becomes in the order of n. So that's the problem with that approach with the array, but with hashmap we are reducing it to like in the constant time. So let's go to the solution. You will understand what I'm saying even more when we go through the steps. So I have created created the notes that I will be sharing. I write the steps which makes it easier for me to understand or go through the problem once again. If I want to revise I just go through the steps, and I don't have to go through the code and understand it always. I just have these steps and written, and it helps me a lot. So I will go through the steps, and then I will go through the code as well. So what's the first step in the solution? I've written that the time complexity is in the order of n, and that is why this is the best solution, because the brute force approach was order big O of n square, if you remember. So the first step is create a hash map. So we have created a hash map here, key and value I've written, and then run through each element e. So for example, I have this array. I've kept it one. We have this array with the elements 1, 2, 3, 4. We will be going through each of these elements and then subtract e from target t. So we are going to, suppose if we are at this element, the first element, we will subtract 6 minus 1 and we will get 5. So why are we doing that? So basically, if suppose we have 6 and two numbers, we have to find out two numbers. If we want to check if those numbers, if the one of the number is 1, then the other number has to be 6 minus 1, right? It has to be 5. So 1 and 5 will sum up to 6. So we are subtracting 1, and we check in the hash map if it is present or not. If it is present, then we return the index, this element's index, the ith element, like the e's index, and the t minus e's index, which will be saved in the value of the hash map. If no, save e and its index as key value pair in the hash map. Let's go through it. So I will be doing dry run approach to understand the solution. Dry run, I started coding using understanding solutions using dry run in my school. At that time, not everyone used to have laptop or any PC in their home. So if we had to understand the solution in the home, or if there was any homework, we used to go through the steps using dry run, and that used to be very helpful. And I think this is going to be helpful again. So let's go through it. So run through each element e, subtract e from. So for the first element, let's go index 0, element 1. What is going to be the element 2? Element 2 is basically target minus element 1. So 6 minus 1 is 5. Now check if t minus e is present in the hash map. Is it present? No, it's not present. It's not present. So we save what if no, save e and its index. E is 1 and its index is 0 in the hash map. Okay. And we did not find the index 2 because 5 was not present yet. Let's go to the second one. So index 1 element, index 1 element is 2. 6 minus 2 equals to 4. Is 4 present in the hash map? No, it's not present again. So we save the element and its index as the value. Now let's go to the third element, that is index 2. 6 minus 3 is 3 again. Is 3 present? No, it's not present. So we again save 3 and its index as the value. Now the last one, right? Now we are in the last one. Yes. So 4. Is 6 minus 4 present? 2. Yes, 2 is present. So what's the index? So index for the element 2 is 1. And when we find out the index, we just return both the indexes. Return value will be 3 and 1. And that's the solution. You see, we went through the array only once, and that's why the time complexity is ON. And that's the beauty of this using the hash map instead of array, because to search any element we did not have to go through each of these numbers, right? We search for any key and we get the value in the constant time, and that's the beauty of using an hash map. Now I will go through the code. The code is where, if we understand the steps, the code is very simple because we just follow the steps and write the code. Let's go to the code. So as I wrote in the solution, so this is the code, the optimal approach for the optimal approach. We create the hash map and then we go through each of the element only once, that we create a loop, and again diff is equals to target. So this is basically element 2. We are finding the element, what is the element 2? Target minus nums I. We check if the map hash map contains the element 2. If it contains, we return this I, this index of the first element and index of the second element. That is map.getDiff will give us the value for the key, that is diff, that is the index basically. And if it is not present, then we store the element and its index as key value pair in the hash map, as I just shown in the notes. And if we do not find out it, we will send null. And that's the solution, guys, and that's the easiest solution, and it's the first, as I said, this is the first problem in LeetCode. It's simple, but for me, for me it was difficult for me to understand why are we using hash map, what is big O, and why is it O1 and ON. And if you are also starting, it might happen that even after watching this video you will have to go through like few other things and to understand, or like code it and understand it more. So I will be sharing the code with you on in the description, so it becomes easy, or in the comments I will check what's the easiest way. So I will share the code there, and yes, please do comment, or for sending or for giving me any feedback that what you felt watching the video, or what would you like me to do more. Please like the video if you enjoyed it, and I'm very thankful that you came till this end of the video. I hope it was somehow was insightful and helpful for you. Please do comment, and please subscribe to my channel, because I'm just very new content. I'm starting my content in YouTube, and this subscribe will be a great support from your end, and this would make my day. Whenever, even if one subscriber, I get one subscriber, it makes my day. Thank you so much for watching the video. See you in the next video, and all the best for your journey. And this journey, I promise, it's going to be very enthusiastic, and it's uncomfortable in the beginning, but I am very hopeful that it's going to, even the questions are going to get tough, our journey is going to get more comfortable, or we will understand the approaches, and it's going to make us feel good anyway. So I'm very hopeful for this journey. I would invite you to this journey. Let's do it together, and let's crack the DSA, and let's make it easy. Thank you so much for for watching the video again. See you in the next video. Bye.